Hi, good morning, everybody, and welcome to the webinar. Apologies for the delayed start. We're just hoping to get some people connecting in who are having some trouble, but I think we might as well get to go now. Just so that the attendees are aware, this recording is being recorded, so if you want to watch this session again later and pick up some more information, you're more than welcome to. We'll get the links to you once it's available to watch offline. We're just going to discuss today about is your authentication really two-factor? So if we take a look at the agenda, things we're going to go through is why authentication is only one factor, something that may surprise a lot of people, when to use two-factor or even three-factor, so it's about appropriate use cases, when will 1.5 factor suffice? This is an interesting new way of authenticating that's maybe not be familiar to a lot of people, but fits a lot of interesting use case scenarios. And the latest innovations in authentication, what's new, again, fitting in different ways of doing things that you might not be familiar with. And how can you roll out multi-factor authentication in minutes across your organization? This is also a bit of a shock to a lot of people because the perception is that this is hard to do. Deploying authentication has traditionally been very difficult, it's expensive and time consuming, but it no longer has to be that way, and we'll explain that to you as well. And of course, at the end, there's some time for questions and answers. You can just type things into the chat window and we'll happily respond to any questions that come up. Okay, so going back in time, just as a recap of where we are. So we'll start at 3000 BC and work forwards from there. So sort of way back in the Egyptian times, we've got the notion of sort of cartouches with hieroglyphs, which were actually used in certain places as basically passwords, or a way of encoding information and keeping things secret. And it worked on the basis of a shared secret. So a password is not really anything that's new. It's kind of been around a long time. And through many thousands of years of evolution, all the way through till 1961, when we started getting the first sort of terminals and dark screen machines where we can log into, guess what, enter your password. So not really a lot have changed in sort of 5,000 years of evolution or trying to prove who you are. And you think about still today when you're logging on to most systems, and most things still want you to enter a password. So again, in the next 50 years since then, still not a huge amount has changed. So we think it's more than time that did. So just looking at the password, the only reason to bring it up really is because we all have them. We've all got too many of them and we're all sick of them. They don't ever seem to go away despite the problems that goes with them. So part of the problem is, we're told to make a password secure. You need to make it long, complicated, and you must change it regularly. This is something you'll see on all the audit reports. The auditors like to do their tick boxes, say you must turn all these settings on to make them secure. Just a reality check, no, it doesn't actually work. So literally in the last 50 years, we've made passwords harder for humans to remember and easier for machines to guess. It doesn't matter how complicated it looks for a human, for a PC to brute force it or attack it is really not difficult. So all these complexity things don't really solve the problem whatsoever. So it's one question about passwords. Are they secret? The only way to keep a password safe is to never give it away, which sounds kind of obvious, hence the post-it note problem. However, every time we use a password or a PIN, we give it away. We're typing in the whole thing and pressing enter, and we don't know what's actually reading it or using it along the way. So this is a fundamental flaw of a password. To keep it secure, you've got to never use it, or at least change it every single time you do. It's just something that never really happens. So looking at passwords and the way they're typically attacked, this has changed over the years with different attacks that have been going on, and we'll just quickly look at the different ways we've tried to mitigate that in IT as time goes by. The common one is a brute force attack, so that's sort of trying to log on multiple times to guess the password, and machines can do that pretty quickly. So things like account lockouts got introduced, so after 5 bad logons, the account's locked out and it stops the brute force attack. It's a common way. The other common way is then copying a database of passwords so that you can then retrieve them. Think TalkTalk in this example is is a very prime case of how things are done. So we did things like salting, hashing, encrypting copies of passwords in databases. Well, at least TalkTalk wished they did, but that's normally what you would do. Another problem the passwords face is keylogging. So this could be done through malware or hardware devices that physically steal the password as you type it in. So it comes down to physical security of the machine and the endpoint to try and ensure that those malware and capturing devices are not physically attached. The wares categories, this is back to spyware, malware, antivirus, etc. So it's a bit like the keylogging, it's just a software version of it. You've got to have all this, anti-that installed to protect the endpoint device from malicious applications that can capture passwords. Phishing, again, this is kind of attacking the user to a degree, but this is the way you fool people into actually giving their password away. So it's kind of the really lazy way of doing the malware. You just ask the user for their password and they give it to you. It's through a bit of trickery. So end user education is kind of the cure for that one, which is even harder to do because most users really don't care. It's not their job to care. They just want to get on. Reusing passwords. It's very, very common. We all have too many logins and we don't remember a separate password for every single one. So typically we're going to write them all down or store them somewhere else. Or you use the same one in multiple locations, in which case, when Twitter gets hacked and then Facebook suddenly asks all users to change their passwords. It's because they know that users are going to use the same password between both sites, and compromise one, you've compromised multiple. So one possible solution there is single sign-on solutions. And of course, human nature is one of the biggest problems of the password. Like I've just said, everyone writes things down. They'll reuse the same ones. They're lazy. They don't want it to be secure. They want it to be simple because that's just the way humans work. Passwords do not fit very easily with the way human beings think and process information. So maybe we should replace everybody with cyborgs. But the classic example there was when Prince William was taken, a photo taken of him in the background was the logon details to some military application, which was quite funny. But this, you can Google this type of example. There's loads of times there's been people standing in office blocks and office buildings with whiteboards behind them with press interviews with usernames and passwords and Wi-Fi keys and things written on the board behind them. That just kind of undoes the point of it being a secure, secret bit of information. So some common attacks. We've probably seen some of these before. Key logging from ATM machines, stealing a card PIN codes to stick fake keyboards on top to capture PINs. Stealing passwords. This is the hardware devices you can stick into the back of a PC. It'll just capture keystrokes, including passwords. The post-it note problem that everyone's familiar with. Stealing identities, skimming of credit cards, for example, in machines, and there's lots of ways of doing that. And stealing any secret information that might be on your machine through malware. Now, this stuff's real. This happens every day. This is what the world is facing, and you can see examples of this in the press all the time. But then people think, well, I've got two-factor oath authentication, so I'm safe, right? It's the common thing. We implement security, then we've solved the problem. Well, actually, this is a reality check here. Oath two-factor is only one factor. So if anyone has got one of these, just keep in mind you have not bought two-factor, you've bought one-factor. You've bought something you have. It's a keyring, it's a token, it's something to prove something you have. It's only one factor. The second factor is still a PIN code or a password. So the reality is here, these oath-based solutions is just sort of sticky tape, adding something on top of the problem of the password. It's not got rid of it. It's added an extra layer, which is mostly seen as an inconvenience, but it's not solved the problem of the password in the first place. The knowledge factor is still very, very easy to get around with the oath-based solutions. So these OTP solutions today come in many, many guises. PINs, passwords are still there. There's phone OTP applications, text messages to a phone, hardware tokens, these keyring generators, card readers that the banks give you, which are really clunky and horrible. These are never popular with users. They're typically very, very expensive to deploy and maintain. The replacement cost when batteries go flat. There's logistics costs of stuffing keyrings in jiffy bags and posting them out everywhere. The hidden costs of these hardware tokens is enormous. Text message solutions as well can be a huge issue when people travel and roam and they don't have signal. The problems do go on with them. There's no sort of silver bullet in this space, that's for sure. So looking at some recent attacks, well, there's been quite a few, especially of late. We sort of refresh the slide every month because there's constantly new articles coming out of stuff going on. TalkTalk is kind of a pretty new one, and Vodafone was in the press the other day for having breaches as well. But surprising how many of them are even, the hacks happen even though they've got two-factor in place. So Gmail accounts getting hacked despite using Google Authenticator. Now, JP Morgan was going through a major hack recently, again, kept fairly quiet in the press because they're quite good at trying to keep out of it, but it still gets in there on certain sites where the two-factor authentication was actually used as part of the attack because they're using standard oath-based solutions. And some of the issues with oath is that it just sort of proves that you have something that generates a number, but it has no way of linking that to what you are doing with that number. And that's where you can attack the website and the workflow of the application by actually leveraging the two-factor that's in place. So, we might have heard about biometrics. That's kind of in the press quite a lot. Journalists like talking about it because it's something new and interesting for them, as though this is some sort of panacea. Now, I think there's a good place in the world for biometrics, but I don't personally believe it is the solution to all our problems, and for many reasons. I'm curious on the Q&A after what your thoughts are. But one point to start off with is who stores the biometric data, and do you trust them? Now, how do I change my fingerprint? We change our password many times. How many times can you change your fingerprint? What do you do when you've used up 10 of them? And back to who stores those, and do you trust them? And if your fingerprint gets out there on the latest eBay hack, then how do you solve that problem and put a new one in place? A little bit harder. There's very high false positives and true negative rates. So if you've got even a 1% failure rate, positively or negatively, and you're doing thousands of logons a day, that's hundreds of people logging in that are either getting in when they shouldn't or not getting in when they should. And all of that turns into either security breaches or help desk calls. So that's, again, huge costs. Biometrics is certainly not 100% accurate at all, especially when you're dealing with consumer-grade hardware. We're all probably familiar with the iPhone fingerprint reader. When it came out, it was within hours. There was YouTube videos of how to hack it with a Jelly Baby, some of the extreme examples. But this is the problem of consumer-grade hardware, which is the only thing that's going to be cheap enough to try and deploy en masse. But as soon as you do, then the assurance and quality levels of that biometric data is massively compromised as well. So it becomes very useful from a user convenience point of view, but as a security measure, we should be very, very careful of how we trust this. Cost effectiveness is another one. Because you need dedicated hardware, it's suddenly back to deploying hardware. And which hardware is it? Which platform does it run on? Now, you've got to have the device and platform portability. So if you want to implement fingerprint access, for example, then you've got iPhones and Android devices in your company estate. Well, guess what? There is no common platform that will use a single fingerprint mechanism across both. So you suddenly have to start managing two fingerprint systems to make that work. Does that become cost effective? And then if you get another device, and it might even have a hardware fingerprint reader on it, if you've got a tablet, for example, then how do you authenticate with that? Do you then look at external plug-in fingerprint readers, and then is the user going to carry that with them? Probably not. So then how do they actually log in? This is just some of the realities of biometrics, because you need some type of hardware to interface with the user to scan the fingerprint, an iris, a blood drop, or whatever you're trying to use. So in your environment, just think to yourself, are you still using a password to access company intellectual property, your cloud applications, HR systems, customer portals, remote access to your network, endpoint devices? Managing your internet DNS zone for the IT guys is a pretty important one, because people don't think about that too much, but a good way to hack a website is to attack the DNS and point the website somewhere else, because most of these web providers just use a password. Make changes to your networks and firewalls. Again, a lot of customers still just using Cisco or whatever firewall they're using, just using a password to log in to make seriously core infrastructure changes. pretty scary. From a hacking point of view, it's a good way to attack the infrastructure because those passwords generally never get changed because the IT guys generally think their accounts are the safe ones. That's not always the case. So I just want to pose a question to you. What if there was a password that was easy to remember, but it changed every time you used it? Now, it's a bit of a strange question, but bring it back to a password, because the nice thing about passwords is they don't need dedicated hardware. They're easy to use on every device because they are ubiquitous from that point of view. But the weakness of them is that they're always static and no one remembers what they are. So what if you could have one that you change every time you used it? Well, in that regard, you could suddenly use the same thing to authenticate with across multiple devices with very, very low cost with a high level of security. So it's kind of the best of both worlds. Well, that's exactly what we've got to offer with PinGrid. There's a way of doing that, and I'll show you how this works just as a walkthrough. So PinGrid is one of the 3 authentication solutions we have within our product portfolio. And as you probably see on the slide, 1 license, 3 solutions. So you buy it once, you get all 3. But I'll run through how they all work and why they're all in the box and why they're different. But PinGrid is by far the most flexible and secure solution that we have, and probably the easiest to use as well. So the way it works is we start off with a grid. And within that grid, you've got a bunch of squares, which you have to remember at least 6 of them. So in this example, there's the numbers 1 to 6 is listed there. So that would be sort of known as my pattern. So I remember as a person those 6 squares. It's just the positions that are important, nothing else, and the sequence. So when I come to log on, I get given a challenge grid, which is just a grid with numbers in it. The numbers are all random and don't mean anything in particular. They just signify a position. So all I have to do from a user to log in is I look at my squares and type in the numbers that are shown inside my squares, which would be in this case those squares. So now I get a one-time code of 101502. Now the nice part is the human brain does not have to remember a PIN code or a password in this instance. All the brain has to remember is a pattern or a shape. Now, luckily, most humans are actually visual by the way they work and the way they do things. So shapes are actually very, very easy for people to remember. So if you think about when you get cash out the cash machine, do you actually type the numbers in on the keypad because you're recalling the PIN number? Or is it more muscle memory that's typing the shape onto the keypad when you're getting cash out? Just think about that when you do that next time. Which one do you actually use? And typically, feedback we get is that most people are actually typing in the shape or the pattern without really consciously thinking about the PIN number. So that's the part of what we're leveraging. So the result here of this one-time code is the result of actually knowing what the pattern is and having access to that grid. So the two together produce that one-time code. So now the trick is, what is my secret? So if I tell you my one-time code is 500143, what is my pattern? Now this is where PinGrid is very strong, because when you do a logon, you don't give away your secret information like you would do with a password or even with Oath. Because with Oath, remember, you're still adding on a 4-digit PIN code or a password on the end of it, which could be keylogged or screen scraped anytime. And to be honest, if anyone has got an Oath token out there or an RSA token, when is the last time you changed the PIN code that goes with that token? Generally, no, feedback is it's never. You've got the same PIN code that you were given when you were first given your token. So if now you've got your security solution using a password that you've never changed in 5 years, you've got to really question how secure is that code in the first place. Whereas this is a solution where the secret information is the pattern and you do not divulge it. You don't give it away when you do a logon. So it's a huge different paradigm shift in terms of security. So the reason this pattern is secure is if you've got access to a grid and the one-time code, you can't reverse the pattern. If you try to, you'll see the number 5 is on that grid 6 times. So which square is it? And then that repeats for every number. So you're going to narrow it down to about 65,000 different combinations. Whereas solutions to the market today, you're narrowing it down to 100% of the secret every single time. So the one-time code is as a result of combining something I know and something I have together in a single process. Bit of a mouthful sentence, but the point is, from a user perspective, All they're doing is looking at a grid and typing in the numbers that's inside their squares. It feels like a simple one-step process. Whereas with Auth and other solutions, it's always a two-step process. It's typing in this number on the keyring before the numbers change, and then trying to find the sticky note where they've got their password or their PIN code written down on to log in. And it's all, the difference to the user is quite massive in this regard. Okay, so why using PinGrid? Well, we've got a single user experience for web and mobile, fast and simple enrollment processes. I'll just get this all up on the screen here. Okay, the key thing here is, the low-cost software option. Because we're not issuing hardware at all, this is how we're able to deploy this to hundreds and thousands of users in literally minutes. It's very, very quick to deploy. And integration to existing systems is key, because every network has got different applications and different things on it, and you need to integrate all over the place. And that's where our authentication service shines, with the integration that we can do with standards-based ways of integrating through web services and Radius and a full set of APIs. So in terms of deployment scenarios, where can we use PinGrid? So one thing we've mentioned earlier in the agenda was 1.5 factor. This might be a new concept to some people, and basically all it is the ability to log on with a one-time code without having a second factor. So yes, technically it's only one factor, but it's one factor with a one-time code. Now this is something that's not technically even possible to do with Auth. So this is something we are able to do with PinGrid though, and enables a whole bunch of new scenarios. For example, in the pictures, you can build a grid into a logon page within an application. So when you load the app, you type in your username, numbers appear in the grid, you type in a one-time code. You don't have to have a separate physical device to do that. You can apply the same logic to a web page. So a simple web-based app, it could be logging onto your webmail, where you go up to load up the web page, type in your username, the numbers in the grid appear, you then type in your one-time code. So again, it's a one-time code logon without needing any separate device, no software or hardware. The same could be done on like an ATM screen as well, and if you'd had that available too, it wouldn't matter if the ATM keyboard had been compromised, because you're not entering the actual PIN code that comes with your ATM card. You're using a PinGrid code, which can only be used once. So with two-factor authentication, PinGrid works just the same way. It's just where is the grid being displayed. So in this regard, we can put the grid on a secondary device like a smartphone or a tablet or even a Kindle. It just means it's on a separate device to the one that you're actually using to run the application. That's what makes it two-factor. So this fits very nicely in the common scenarios of like VPN access or any networking radius-based equipment logon. The other thing we can do with the two-factor is also send out text messages or emails as a way of doing the distribution of those grids. This is a second way. The three-factor authentication, which I also mentioned in the agenda, is to do with transaction signing or transaction validation. Now, this is hugely valuable in the financial industry, in the banking sector, and if you're doing internet banking today, you generally do this occasionally, depending on which bank you're with. But you typically not anymore when you have one of those clunky card readers or big calculator type devices from the bank. Well, we can do exactly the same thing with PinGrid, just using our soft token, and in fact it's even easier to use. And we were award winners for this for Macy Magazine a few years ago in terms of the concept. But again, to a user, it feels like a single-step process. Now compare that to what you go through today to add a payee on your bank account with those clunky card readers. It's a painful process every time. That's if you even find your card reader. So to do that, you need an app to do the two-factor and three-factor. So we decided we'll put the app on every app store. So instead of just picking one or two like a lot of vendors do, we'll cover them all, including things like Amazon for your Kindle, the old Nokia Symbian store. So you don't have to have everybody the latest iPhone to make the stuff work. You can run it on pretty much anything. And the other thing to consider in today's world is cloud services. Now, a lot of people are moving applications into the cloud. And unfortunately, every time you do that, you end up with a new username and password for all your users per cloud application, unless you can start doing things like federation, whereby you can use your existing identity you have on your network, which is a good idea to do. But if people are accessing those applications from outside the network, you might not want just logging on with username and password to those. So this is where we can integrate pin grid into this scenario as well, so you get single sign-on, including two-factor authentication onto these cloud applications. So we've just listed 3 common ones there, but pretty much any cloud service you can do federation with, you can use with pin grid in front of it. And that could be in a 1.5 or 2-factor mode. So as I mentioned before, with our solution, we have 3 authentication products in one. So I'm just going to touch on pin phrase and pin pass, which is the 3rd one, just to show you what they are. But they're all part of a single server infrastructure, and you can turn these authentication technologies on or off per user whenever you like, or even have a user set up for multiple at the same time. So pin phrase might be familiar in the way that it works, because you might have seen it before in other internet banking websites before, where effectively it asks you to enter random characters from information you already know. So literally it's going to send you a text message with a question, or it could be into soft token app, or a question directly on the web page. So again, it's a 1.5-factor capable technique, where it's going to ask you for characters 6, second last, and last from your code word, or it could be characters 3, 7, and 9, your mother's maiden name, or it's really up to you how you set this up, because you get to choose what questions are, you get to choose how many answers a user must provide, and then the user provides that information during the enrollment process. So the nice thing with pin phrase is you're not requiring the user to learn and remember anything new. They're remembering things they should already remember. And when they log in, they're not giving away the full piece of information like when they're entering a password, because they're only entering certain letters or characters from what the memorable information is and not giving it all away. So it also adds some protection against keystroke logging and malware. And last but not least, the 3rd solution we have in our portfolio is pin pass. Now, pin pass is literally an oath compliant solution. So as much as I've talked about oath and its limitations, the reason we understand very much what those limitations are is because we have one of the same solutions. So if you're looking for a very simple migrate over from what you've got onto our platform without having to retrain or re-educate the users, pin pass is a nice intermediary step where you can change the plumbing over, and users don't know much has changed until you gradually start enabling them for other authentication types within different applications, and you can move things over. So with our oath-based solution, again, it is no software, it's all software. We don't provide any hardware tokens, so we try and still go by that way of doing things. So that keeps costs down. So typically it'll work through a soft token, or very commonly through text messaging. So we tried to make it a bit easier as well, and get over some of the hurdles with oath. So for example, we can pre-send codes, generate oath codes, and send multiple in one text message. So it cuts down on text message costs, and also means that if a user doesn't have signal at the point they need to log on, they don't have to wait for a text message to arrive. They can have it waiting for them on their phone for when they do the next log on, and they can have multiple codes they can use. And once they've used up the last code in the text message, the server then sends them a new one for next time. So you can do preloading, or we can do real-time sending, which is what you're probably familiar with now with text message-based oath. So you've got choice per user how you want that to work. The other thing we can do with this as well is, because we do native Active Directory integration, you can use your Active Directory password as the oath pin, if you like, because in theory, your Active Directory password is probably going to be a bit longer and more secure than a 4-digit PIN, and you probably already have a policy to change it every 30 or 60 days, which is something the user is already doing. The user should already be remembering their password to log on more regularly. So again, it's not requiring them to remember something in addition, which is probably less secure anyway. But we also give the fallback option of having a traditional separate PIN code if you want that. All right, another common thing you can do with our solution is logging onto Windows. Now, this is something that's getting more and more interesting these days, because so many thick client applications that run on the PC that don't support two-factor. So how do you provide protection for those applications? And the most logical way at the moment is to do it right at the Windows logon process. So if you can't even log onto the PC, you can't get into any of those thick client applications. So The nice part about this is that we can support 1.5 and 2-factor authentication into Windows, all through group policy controls. So I can be totally offline, working in Starbucks, no internet connection, and I can still do a 2-factor logon using the app on my phone to get into my workstation. So any of these sort of scenarios you can think about when you use a password, we support the same ones in Windows. So we do know there are some vendors that have a similar solution for 2-factor logon onto Windows desktops, but they tend not to work too well when you're sipping your latte. So with our group policy, our desktop login agent, you can configure and deploy the entire thing using group policy. So there's nothing to configure on the workstation. In fact, there is no configuration GUI on the workstation. Everything is group policy controlled. So you can build in many different configurations you want to sign into servers and workstations, whichever way around you want, to support online, offline, logon, 1.5 or 2-factor. You can really slice and dice it, whatever policy you like to be for your environment. You can also use this with PinGrid, with PinPass or PinPhrase. So most of the agents things you see within the solution, you can use any of the authentication types with. Okay, a common thing you need to do with multi-factor authentication as well is self-service. So that you let users do as much things themselves as possible, because it means they can do it in their own time. It cuts down on help desk calls, and generally it cuts costs overall. So the ability for them to manage their authentication methods themselves. In other words, they want to go and change their mother's maiden name, or they want to change their PinGrid pattern, or they want to change or reset their Active Directory password, or unlock their Active Directory account even. They might have now got a new Galaxy S6 and they want to remove their old one and add their new one on as a 2-factor device because they've got a new device. Well, guess what? They can do it themselves. It doesn't have to be a help desk function. There is even products in the market that will all they do is Active Directory password reset and management. So this is something you kind of get as part of our solution anyway. Help desks as well need to be able to do things still on behalf of users. Sometimes there are things users can't do themselves. So we've got a simple web-based tool that help desk operators can use to do more advanced things for a user, for adding and removing devices, managing their authentication settings. The nice thing is also just proving who the user is. So a common thing at the moment with customers is when a user calls the help desk to ask them to do something, how does the user on the phone prove who they are? Now, typically today they don't. They just kind of say, "Hi, I'm George from accounts. Please, will you do X, Y, Z?" And they just say, "Yeah, sure," and they just do it. And it's quite scary. So help desk can use this as a simple way of leveraging the 2-factor to prove who the user is over the phone. So the help desk administrator can trigger the sending of a token to their phone, generate a PinPhrase question, and when they get the response back from the user over the phone, so the user might just load up their app on PinGrid and read the 6-digit code. The help desk administrator can then type that code in onto their help desk portal, click validate user, and the portal will tell them, is that a valid code for the user or not? And it's a really good way of proving who the user is at the help desk without asking them a whole bunch of silly questions that you probably still don't trust the answer to. So for the more technical minded, on the server side of things, the way our product works is it's a very simple and easy to use piece of software. So it's not custom hardware. It's literally a very small Windows installer that runs on Windows Server, very familiar management tools, all Microsoft Management Console based. So if you can use Active Directory tools or use any of those sort of standard Windows tools, this is kind of pretty familiar. You're not going to need a lot of training to use this. A lot of solutions in the market, you can load up the GUI and have no idea where to start. It looks very alien. The language it talks, the terms in it don't make sense. So we try to make this very familiar wizards to run you through the process of doing things so that you've got confidence that what you've deployed is actually secure. So you can typically do a full server installation within 10 minutes. Now this supports sort of small single server installations up to multiple high availability, regional availability deployed solutions. So however many servers you want to deploy, you can deploy. Just install them. We primarily use Active Directory as our accounts database. So we don't do synchronizing of accounts from AD into a local database, which tends to always go wrong. Over time, directory synchronization is a nightmare of a process, so we don't do that. We use Active Directory as a database. That's what it was designed for in the first place. So that cuts back on a lot of issues. It also means your authentication server is not actually holding your directory data. It's stored in your Active Directory. So our server does support Radius and web services as well, so it's very easy to integrate external applications and networking equipment and things with. So it can scale as big as AD can scale. So, if you've got 100,000 users in Active Directory, well, guess what? They're already in the Active Directory. So the directory already supports a number of users. So it's then up to you to decide how many servers you might want to deploy because of high availability or where they are in the world. That's up to you. We don't charge for the server software either. It's just part of what you get when you buy the user licenses. So it's really it's purely from a technical perspective how many servers you might want to deploy. All right. So that's about it from my monologue from the slide decks. More than happy to take any questions, it may be about the products or just thoughts or concepts or the experiences you've got in terms of the products you use or issues you found. If there are any questions, please do just type them into the chat window and happy to answer them. But otherwise, thank you for attending the webinar today. Okay, we've got one question in here saying, with PinGrid, where is the grid pattern stored? Okay, the pattern, being the thing that you have to remember, is stored on the authentication server. Well, it's just technically encrypted in the Active Directory in terms of physical storage, but it's only accessible via the authentication server. It's never ever stored in the soft token app or anywhere. There is no ability to store it inside the soft token. So losing your phone does not compromise anything because it's not stored on there at all. So it literally is on the server and in the user's brain is the only other place that we store it, which is why it keeps it more secure because it's not copied all over the place. Okay, another question about the licensing model. Is it concurrent, etc.? Yeah, the licensing I didn't delve into too much. I'll quickly run through it now. I know everyone says they keep this simple, and I always chuckle when I see Microsoft say that. But we've tried to do just that with our solution. So we literally just charge per user. So if you've got 100,000 users and you want 1,000 of them to have multi-factor authentication, you need 1,000 licenses. Simple as that. And then they can use any of these authentication technologies that we have within the product. So you don't have to license all your users, just the ones you want to use for multi-factor. Once they're licensed, then they can use most things in the product out the box. We don't charge for soft tokens at all. They're free downloads from the App Store, and you just pair them up with a user account and you're good to go. As I said before, we don't charge for the server installation or the server licenses either, so go for your life with that one. We do charge for some agents like the Windows Desktop Logon agent, so that's a per workstation license charge for installing that software onto the endpoint machines. But a lot of the agents we do have are free. Just our integrations into like Palo Altos and a lot of firewalls or Radius devices, we don't charge for any of those to connect in. It's just when we've got an actual installation you need to do onto an endpoint, typically we have an agent fee. But for the most part, most scenarios, it's just charging per user. So there's no sort of concurrency because a logon event takes like milliseconds, so there'll only be one user at a time if that's the case. So it's literally down to number of named users. But because this is all software, you can always remove a user from the server, which frees up a license. You can reassign that to another user. So yeah, you've got flexibility there. And the other thing you're able to do is something unique to us is you allow you to assign up to 10 different soft tokens per user. And that's still only using one license because the user is licensed, not the soft token. Because we recognize in the real world people have got a laptop, an iPad, and a phone, and multiple things. So if you can pair them all up with your account, as long as you've got one of them with you, you're able to do a two-factor logon. Whereas all the competitors out there, it's a one-to-one process. So if you suddenly lose your iPhone or it's flat or something, you can't load up your soft token, you can't get in, and you don't have an alternative. And then you start phoning help desks and going through a horrible process to get in. So with our solution, you just fire up another device that you do have with you or does have power and log in. It makes life a lot easier, although we do still have emergency override processes in the products as well, but we tend not to need them. Cool. So is there any other questions coming through at the moment? Okay, well, nothing's coming through as yet, but would anybody else like to leave some comments or say something towards what they think about it all, how that relates to what they're using today? I'm happy to unmute you and contribute if that's the case. This is where everyone normally gets shy. Okay, no, seems not. Well, it's worth a go. Okay, well, if that's the case, we'll leave it at that. And thank you very much for your time today and attending the webinar. We will follow up with some emails and some links so you can look at this presentation again afterwards. And hope you have a good day. Thanks very much, everybody.